So today we are looking at geometric sequences. A geometric sequence is a sequence of numbers where we're repeatedly multiplying by the same amount every single time. So for example, table A, notice as x increases by 1, f of x is being repeatedly multiplied by 3. And that's what makes this sequence of numbers a geometric sequence. Okay? Now, we can write two different equations to represent that geometric sequence. The first one being explicit. Okay? So, to write an explicit equation for the geometric sequence, first off, we know we're trying to find f of x, so I'll say f of x is equal to. Now, you need to know what the sequence starts at 0. So notice, when x is 0, f of x is 2. So we know it starts at 2. Okay? But after that, it repeatedly multiplies by 3 over and over and over and over again. So we're going to multiply by 3, but not just one time, multiple times depending on what value of x we're using. So that means to represent repeated multiplication, we're going to multiply it by 3 to the x power, because exponents represent repeated multiplication. So any value of f of x that we're looking for, we just take 2 and multiply it by 3 to the whatever power we're looking for. For example, if we're trying to find f of 4, you'd have to do 3 to the 4th power and then multiply it by 2. Okay? And that's what an explicit equation will look like for a geometric sequence. Because we're repeatedly multiplying, it's going to have an exponent in there, because exponents represent repeated multiplication. Okay? Now, for the recursive equation, recursive equations represent an equation that's based on knowing the previous value. Okay? So, I'll start my recursive equation by writing now, because we want the current value. Okay? Now, to figure out the current value, we take the previous value, and based on our pattern, we take the previous value, multiply it by 3, and then we get the current one. So our formula is now is equal to previous times 3. And there it is. And that'll allow us to get any value of f of x. All you have to do is know the previous one and multiply it by 3. And later on, we'll learn a more mathematical way of writing this out. But for now, this is what we're looking for. Okay? Just to make sure you understand recursive equations. Okay, let's do another example here. Okay, table B. We've got some big numbers here. But notice, as x is going up by 1, f of x is actually dividing by 10. But another way to think of dividing by 10 is thinking as multiplying it by 1/10. So this is a geometric sequence, but we're multiplying it by a fraction and it's getting smaller. Okay, not so bad. But now that we figured that out, let's write our explicit equation. To get f of x, we know at 0, it starts at 20,000. I'll put a comma in there. And we know we're going to take that number and repeatedly multiply it by 1/10. So I'm going to put 1/10 in parentheses, because since we're repeatedly multiplying by 1/10, we have to raise it to the x power. And that's our explicit equation. F of x is equal to 20,000 times 1/10 to the x power. All right? Now let's do the recursive. To get the current value that we're looking for, we base it off the previous value. So, for example, if I was trying to find this one right here, I'd look at the previous one, which is 20, and then multiply it by 1/10. And that would get me my current value. So there's our recursive formula. The current one now is equal to the previous one times 1/10. Okay? So that's it for geometric sequences. Hopefully you found this video helpful. If you did, please hit that like button. Also subscribe because it really helps us out. But that being said, good luck on your math, and I will see you next time.